In this class, we will discuss how to construct the confidence interval for the mean. Right? Well, see the problem here. The mean and standard deviation of a population are 11,795 and 14,154. What can one assert with 95% confidence about the maximum error if x bar equal to 11,795 and the sample size n equal to 50? Also construct a 95% confidence interval for the true mean here. So first write down the given data. So it is clearly given that the sample size is 50. So that means n equal to 50. The next, the mean is sample mean is given as 11,795. Okay, and the standard deviation is given as 14,054. So sigma equal to 14,054, and with 95% confidence we have to find the mean maximum error of mean and also the confidence interval of mean here. So that means here Z alpha by 2 is 1.96. So with 95% confidence means Z value will be 1.96 here. Now first we have to find the maximum error. So the formula for maximum error is Z alpha by 2 into sigma by root n. That means 1.96 into 14,054 by square root of 50 here. So first find out the square root of 50, right? Then divide with 14,054. Then multiply with 1.96. So it is 3895.57. Now we see here the mean and standard deviation are rounded to one particular number. So here it is given as 3895.57. So that means approximately the maximum error is 3895. Now next we have to find the confidence interval. So for confidence interval the formula is here x bar plus or minus Z alpha by 2 into sigma by root n here. So that means here x bar means 11,795 minus, so Z alpha by 2 into sigma by root n is nothing but the error only, that is 3,895, comma, again 11,795 plus 3,895. So this will be the confidence interval here. Now simplify this. 11,795 minus 3,895 is 7,900, and 11,795 plus 3,895 is 15,690. So the confidence interval for the true mean means for the sample mean is 7,900 to 15,690. So in this way we have to find the confidence interval. Now sometimes instead of asking the maximum error, they will ask you to find directly the confidence interval. But to find the confidence interval, again we have to find the error only. So if they ask the question like finding the error or not, ultimately to construct a confidence interval, we have to find the error. Okay? So this is about the confidence interval for mean. Now let us see one more problem on confidence interval for mean here. A random sample of size 81 was taken whose variance is 20.25 and the mean is 32. So construct a 98% confidence interval. Now this time instead of 95% they asked to construct the 98% here. So if you see the problem here, sample size is given as 81 and here variance is given as 20.25. That means you just find the square root of variance, that will become the standard deviation. So square root of 20.25 is 4.5 here. Then next they have given the sample mean as 32 and 98% confidence interval means Z alpha by 2, 98% value is here 2.33. 95% is 1.96 and 98% is 2.33. Now to find the confidence interval, first we have to find the error here. So error equal to Z alpha by 2 into sigma by root n. So 2.33 into 4.5 by root 81 here. So root 81 means it is nothing but 9. So the error will become 4.5 divided by 9 into 2.33 is 1.17 here. Okay, so the error is 1.17. We can round off it to 1 also. Right? Then the confidence interval is given as here x bar plus or minus z alpha by 2 into sigma by root n. So x bar means here 32 minus 1.17 and 32 plus 1.17. So 32 minus 1.17 is 30.83 and 32 plus 1.17 is 33.17. So the confidence interval for the mean is here 30.83 and 33.17. So if you round off it to integer here, this becomes 1. Then 32 minus 1 and 32 plus 1, it becomes here 31 and 33. Anyway, if you round off here also you can round off. That is 30.8. After decimal you have 8. So you have to round off to the next digit, that is 31. And here we have 33.1. So after decimal you have 1. So the same digit you will get, that is 33 here. So this is the confidence interval for mean. Now let us see the last problem in the construction of confidence interval of mean. So a random sample of 500 points on a heated plate resulted in an average temperature of 73.54 degrees Fahrenheit with a standard deviation of 2.79 degree Fahrenheit. Find a 99% confidence interval for the average temperature of plate. For the average temperature means you have to find the confidence interval for x bar here. So what is the sample size given here? 500 points on a random sample of 500 points on a heated plate means n equal to 500, right? Resulted in an average temperature of 73.54. So x bar, this sample mean is 73.54 with a standard deviation of 2.79. Then find a 99% confidence interval. So the z value for 99% is 2.58. So for 95%, 1.96, 99%, 2.58 and 98%, 2.33 here. Now we have to find the confidence interval. But before finding that, we have to find the error. So z alpha by 2 into sigma by root n. So 2.58 into 2.79 by square root of 500 here. So square root of 500, it is 22.36. Then 2.79 divided by 22.36 is 0.12 into 2.58 is here 0.32. We can consider the error in decimals because here also the mean and standard deviation are given in decimals here. Then the confidence interval is x bar plus or minus z alpha by 2 into sigma by root n here. So here we have used small x bar. So let us use here also small x bar only. So it is here, what is x bar? 73.54 minus 0.32 comma 73.54 plus 0.32 here. So finally it is 73.54 minus 0.32 is 73.22 and 73.54 plus 0.32 is here 73.86. So the confidence interval for the average temperature of heated plate is 73.22 and 73.86. Now till now we have seen if the sample size is given, the sample mean is given, how to find the confidence interval and the error here. Then the next case we have seen is that here the error is given and the confidence level is given, how to find the sample size, how to estimate the size of the sample. Now the third case is here, the sample mean is given, standard deviation is given, the sample size is given. Now this time we have to find the confidence level. That means the alpha value we have to find here. So to find the alpha value, again we have to go through the normal tables. So there I have mentioned the ordinate value of 1.43 as 0.4236. So that's what we have done in the normal distribution problems. Then the normal distribution, to find the probability of between random variables, we used to find the table value of the ordinate. So here the ordinate is 1.43, further the table value is 0.4236. Now if you move on to the problem here, in the study of an automobile incident, a random sample of 80 body repair cost. So 80 is nothing but here the sample size. Repair cost had a mean of rupees 472.36. That means sample mean is 472.36 and a standard deviation of rupees 62.35. So sigma value is here 62.35 here. If x is used as a point estimate to the true average repair cost, with what confidence we can assert that the maximum error does not exceed rupees 10. So with what confidence means they are asking you to find the alpha value here. If the maximum error does not exceed rupees 10, that means the error is given as here 10 rupees here. Now to find the alpha value here, we know the formula for maximum error of mean as z alpha by 2 into sigma by root n here, right? So from this, what is z alpha by 2? Z alpha by 2 is e into root n by sigma, right? If you just cross multiply this. So that means here z alpha by 2 is equal to e means 10 into root n means root 80 by sigma is 62.35 here. Now first find out the root 80. It is 8.94 into 10 divided by 62.35. It is 1.43. Okay, so this is the z alpha by 2. Now find the z value of 1.43. So z value of 1.43 means the table value of 1.43 is 0.4236. Okay, now we have to find the value of only alpha. So from this, alpha is here 0.4236 into 2. So that means alpha equal to 0.4236 into 2 is 0.8472. Okay, but remember here, always the confidence level is given in terms of percentages. So into 100% means the confidence level is here 84.7%. If you round off, it is 85% confidence. So with what confidence can we assert means with the 85% confidence we can assert that the maximum error does not exceed rupees 10. So to find the confidence level here, we have to use the normal tables. Is it clear how to find the alpha value? I hope you understand this alpha value.